Okay, here's another example. Determine what the key terms refer to in the following study. A study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. Fill in the letter of the phrase that best describes the items below. Okay, number one, the population. Well, the whole population was not the students who attended the college last year. It was the students who graduated last year. So your population down there would actually match up with F. All students who graduated from the college last year. Your statistic. Number two. The statistic we're looking at is the average cumulative GPA of students who graduated from the college last year. So G would be your statistic there. Your parameter. Number three. Okay. What you are actually... Okay. Right here, the difference between G and E is in this study. That's what is the difference between a statistic and a parameter. This average cumulative GPA just limits what it is you're studying. That's what makes it the parameter. In the study is what makes it the statistic. So look for that when you're trying to decide which one is which. Number four, the sample. Okay, the sample is pulling students out of all the students. So let's see what we've got here. It can't be all the students. There we go. A group of students who graduated from the college last year. So that would be D for your sample. Okay, 5. Your variable is that, remember how last one, see if I can get it to move up. How the last one went with the one first-year student? So that's what we're going to do here for your variable. Go with the one student if we can find one. There we go. B is the cumulative GPA of one student, B, and then your data in there. Well, there you go. C, when you've got actual values that you're looking for. Okay? So, right here, determine what the key terms refer to in the following study. As part of a study designed to test the safety of automobiles, the National Transportation Safety Board collected and reviewed data about the effects of an automobile crash on test dummies. Here is the criterion they used. Speed at which cars crashed, location of drive, the dummies where they were, 35 miles per hour, front seat. Cars with dummies in the front seats were crashed into a wall at a speed of 35 miles per hour. We want to know the proportion of dummies in the driver's seat that would have had head injuries if they had been actual drivers. We start with a simple random sample of 75 cars. Okay? So, the population is all cars containing dummies in the front seat. Okay, so that is the population. Got sample and statistics reversed, but that's all right. The statistic is how many, or the proportion of dummies that would have had head injuries. Okay. Your parameter is the same thing in the population, the proportion of dummies with head injuries in the population. Okay, that's the same thing right there. Sample is the 75 cars. 75 cars out of the population. Okay. Your variable. Okay. Your variable is the proportion, the number of drive, not the proportion, the number of dummies with head injuries. Okay. And the data is either yes, the had head injuries, or no head injuries. Okay. A lot of these are very close to the same thing. That's why I was pointing out different words and things that would make it different from, to distinguish from each other. That's the kind of thing that you need to do in all of this. So here we go, population, sample, parameter, statistics, variable, and data again. This one I want you guys to go ahead and answer this and submit it with the next question that I've got for you. There is one more that you're going to have, and you'll submit that as your assignment for this. Okay? All right, data and variation in data. Qualitative data are the result of categorizing or describing attributes of a population. This is what they're talking about: hair color, blood type, ethnic group, the car a person drives. You could even classify cars, the white, blue, green, whatever, by color. Or you could classify them by what type they are. Are they SUVs? Are they sedans? Are they convertibles? Are they trucks? Those would all be qualitative. Quantitative are always numbers. Quantitative data are the result of counting or measuring attributes of a population. Amount of money, pulse rate, weight, number of people living in your town, and number of students who take the statistics. Notice number of is going to make it quantitative every single time. Okay? So, quantitative data may be either discrete or continuous. All data that are a result of counting are called quantitative. These data take on only certain numerical values. If you count the number of phone calls you receive for each day of the week, you might get values such as 0, 1, 2, or 3. All data that are the result of measuring are quantitative continuous, assuming that we can measure accurately. Measuring the height of athletes in centimeters might result in such numbers: 183, 172, 191, and so on. But these measuring are quantitative. So right here, here's an example of quantitative discrete. The data are the number of books students carry in their backpacks. You sample 5 students. 2 students carry 3 books. 1 student carries 4 books. 1 student carries 2 books, and 1 student carries 1 book. The numbers of books, 3, 4, 2, and 1, are the quantitative discrete data. You can actually count them. All right, data sample of quantitative continuous. The data are weights. Weight is a measurement. Okay, so if it's measuring, then it's continuous, quantitative continuous. It's numbers, but it is continuous because you're measuring. Okay, notice the backpacks carrying 3 books can have different weights. Weights are quantitative continuous data because they're measurement. All right. So, example 1.7, you go to a supermarket and purchase 3 cans of soup, 19 ounces tomato bisque, 14.1 ounces lentil, and 19 ounces Italian wedding. 2 packages of nuts, 4 different kinds of vegetables, 2 desserts, and 32 ounces of chocolate chip cookies, just your type of desserts. Name data sets that are quantitative discrete, quantitative continuous, and qualitative. Okay, quantitative discrete. Okay. When you describe the 3 cans of soup, 2 packages of nuts, 4 kinds of vegetables, and 2 desserts, That's quantitative discrete data because you're counting out how many you have. When you're talking about the weights of the soup and the ounces and the measurements of the pistachio ice cream and the chocolate chip cookies, that is quantitative continuous. That is weights. So you're measuring things. Types of soups, nuts, vegetables, and desserts are qualitative because they're categorical. So when you're talking about walnuts and peanuts, or you're talking about broccoli, cauliflower, spinach, and carrots, that's qualitative because you are categorizing it according to what it is. Okay? So, right here, the data are the number of machines in the gym. You sample 5 gyms. One gym has 12, one gym has 15. One gym has 10, 22, and the other has 20. What type of data is this? Well, this is just counting, okay? And counting is quantitative discrete. So this is quantitative, and it's discrete because you are counting. The data are areas of lawns in square feet. You sample 5 houses. The areas of the lawns are 144 square feet, 160, 190, 180, and 210 square feet. These are measurements. When you're dealing with measurements, that is quantitative continuous. Quantitative continuous is always about measurements. The data are colors of houses. So this is a category. Okay? When it is a category, it is qualitative. What kind of qualities do they have? So we got category here. That makes it qualitative. All right? The next thing is, this will be the one that you're going to turn in with the others. With the other slide. Other questions. And this will be the end of your assignment. All right. Good luck.